I just had to let you know you're.
Hey everyone! Okay, today we will talk about a massive breakthrough in clean energy that our group has been researching. Ta-da! Okay, we always hear about nuclear fusion as a future, but what if the quickest way to get there is actually a mix of two different technologies? Let's go! Bah! Okay, it's called a fusion-fission hybrid reactor. According to a study by Ragib in 2011, this system basically uses a fusion core to shoot out high-energy neutrons. Surrounding this core is a blanket of thorium-232. When those neutrons hit the thorium, a process called transmutation happens. The thorium absorbs the neutrons, changes form, and turns into uranium-233, which is super efficient nuclear fuel. In short, the reactor actually grows its own fuel right inside the system.
Huh?
Okay, we choose to dive into this topic because it connects two fascinating fields, plasma physics and nuclear engineering. Honestly, it feels like researching the holy grail of clean energy. First, it solves a huge problem called the fusion gap. Right now, pure fusion reactors struggle to stay power without using up too much energy themselves. But rugged research shows that adding a thorium blanket makes things much easier because it multiplies the energy output. Second, it gives us incredible energy security. An official report by the International Atomic Energy Agency points out that thorium is about 4 times more common on Earth than uranium. Since we were learning all of this independently as a team, we had to be smart about how we get our information. First, we set up a database search matrix on Google Scholar to filter out random opinion and focus purely on peer-reviewed studies. Second, we perform a trend analysis by tracking modern nuclear projects globally. This helps us see how textbook physics is actually being turned into real-world engineering right now. But Nisha, can you help me with this patient?
This is so draining.
Of course, studying advanced nuclear physics was not easy. Our group facing some challenges such as information isolation. Fusion and fission scientists usually work in completely separate areas, so finding combined data was tough. To fix this, we stopped looking at isolated physics papers and searched specifically for system engineering documents that look at the reactor as one big connected machine. But it's okay. Let's see what our group members can help you to understand this topic.
Hi guys. Today, I will discuss about thorium as a fuel in fusion and fission systems. Thorium is a radioactive element that can be used as an alternative nuclear fuel. According to the International Atomic Energy Agency, IAEA, thorium-232 can absorb a neutron and eventually become uranium-233, which is capable of producing energy through nuclear fusion. Thorium is important because it is more abundant than uranium and processes less long-term radioactive waste. According to the World Nuclear Association, thorium has the potential to provide safer and more sustainable nuclear energy in the future. Let's move to the facts and examples of thorium in fission and fusion energy. According to the World Nuclear Association, thorium is about 3 times more abundant than uranium in the Earth's crust. Countries such as India and China are actively researching thorium-based reactors. For example, India has developed the Advanced Heavy Water AHWR as part of its long-term thorium energy program. According to research published by IAEA, thorium fuel cycles may produce less long-life radioactive waste compared to conventional uranium fuel cycles. This makes thorium a promising option for future electricity generation. Next, for the application in daily life, I will ask my friends to explain about that.
Now, for the application in daily life of thorium, although thorium is not directly used by the public, the electricity produced from thorium reactors can power home, school, hospital and industry. According to the World Nuclear Association, thorium-based nuclear power can provide a reliable source of electricity while reducing dependence on fossil fuels such as coal and oil. This can help reduce carbon dioxide emissions and support cleaner energy productions in everyday life. For the recent advancement and controversies of thorium, according to the reports from the International Atomic Energy Agency (IAEA), countries such as China and India continuing research on thorium reactor technology. China has been testing molten salt reactor technology, which is considered one of the most promising reactor design for thorium fuel. However, according to the World Nuclear Association, thorium reactors are still not widely used because the technology is expensive and requires further developing and testing. There are also concerns about the cost of building new reactors and managing radioactive material. Despite these challenges, many scientists believe thorium could become an important energy source in the future. Okay, that's all from me. Thank you.
Whoosh! Hi everyone! So now we already know how thorium can be used as a fuel in fusion-fission system. But here's question. Who is gonna make all of this happen? I mean, this reactor will not build themselves, right? So, let's explore some of exciting career opportunities related to this field. One of the career is most closely related to thorium fusion-fission system, which is nuclear engineer. According to US Bureau of Labor Statistics, nuclear engineers are involved in researching and developing nuclear technologies, designing new reactor systems, and making sure nuclear facilities operate safely while following strict safety regulations. But designing and operating reactor is only part of the story. Before any new energy technology can be used in the real world, someone has to test it, improve it, and figure out what works and what doesn't. So that's where fusion energy research scientists come in. Fusion energy research scientists are people exploring and advancing fusion energy technologies, which aim to provide cleaner and more sustainable energy for the future. Okay, thank you. According to US State's team, their work include designing and operating experiment fusion reactor, analyzing data, and collaboration with scientists and engineers from different fields to improve future energy system. So now we know who is involved in developing thorium fusion-fission system. But the question is, how do you actually become one of, these amazing people? Thank you. Is passing physics enough, or do you have to be genius like Einstein? Don't worry, there are actually several important skills that can help someone success in this field. Let's go! First of all, having a strong foundation in physics and mathematics is essential. In nuclear energy field, these skills are extremely important because scientists and engineers need to understand how nuclear reaction works and how energy can be produced safely and efficiently. Besides that, problem-solving skills are also very important. In real world, things doesn't always go according to the plan. Sometimes a system may not perform as expected. So engineers and scientists need to identify the cause of the problem and come up with the best solution. Oh, finally, another important skill is being comfortable with technology and data analysis. This is because scientists and engineers use computer simulations, collect experimental data, and analyze results to improve reactor design and energy system over time. They also need to know how to use technology for research, innovation, and development. That's all from me. Who knows, maybe one day one of us will be involved in developing thorium fusion technology that will help power the world with cleaner and more sustainable energy. Safira, I've been explaining about career in thorium reactor to them. But honestly, why should I care about continuous self-development?
I just want a stable job after my graduation.
Yo, chill, calm down. That's why we need to talk about it, Shaliza. I will give you 3 reasons and all relevant to us as Malaysian students. First is the Malaysia's upcoming nuclear workforce gap. According to the Minister of Science, Technology and Invention of Malaysia, it said that if Malaysia move forward with nuclear energy, we will need between 700 to 1,000 nuclear professionals. But right now, we have only about 30 dedicated personnel in the country. And for me, there is such a huge gap, and by continuous learning is how we become qualified to fill it. Number 2 is the technology evolved faster than our syllabus. The fusion-fission hybrid system we're studying right now, well, 5 years ago it was just a theory. But today, China and Russia are building prototypes. And as the technology advances, simulation software, reactor materials and safety protocols are constantly updated. So if we stop learning right after graduation, our knowledge can quickly become outdated, just like a smartphone that never received any software updates. So by continuous self-development, it helps us to stay current with the latest developments and remain competitive with our careers. Well, number 3 is the skill developed in nuclear studies are available beyond the nuclear industry. Based on my research, even if Malaysia delays nuclear energy development beyond the 2030, the skills we gain are still highly useful. Skills such as simulation coding, radiation safety, and data analysis are already being used in many industries today. And these include nuclear medicine in hospitals, semiconductor manufacturing in Penang, and even the oil and gas sector through companies like Petronas. And this means that the time we invest in developing these skills will not go to waste because they can lead to a wide range of career opportunities.
Okay, I'm start to see the point. But what are the real challenge for us in Malaysia and how do we overcome them?
Good question. Let me walk you through 3 major challenges and practical strategies for each. Challenge number 1 is the limited local opportunities and timing uncertainty. According to the President of the Minister of Energy Transition and Water Transition, Datuk Sri Fadilah Yusof, the government final decision on nuclear energy is only expected after the 2030. That means the commercial reactors might not appear for another 10 to 15 years. So where do we work in the meantime? And that is every science student's biggest fear, graduating with a nuclear physics degree and no local job. So to fix that, I come out with the strategy number 1, which is to go international first and then return as an expert. Countries like China, South Korea, and France and Russia are actively building advanced reactors. So we can work there for like 5 to 10 years and gain hands-on experience and then come back when Malaysia is ready. However, if we decide to stay, you can also work in nuclear medicine, radiation safety, or non-destructive testing, which is all of them are growing fields in Malaysia right now. Next is challenge number 2. Some people complain, but studying is expensive. But the government wants to develop their own experts. So I come up with the strategy number 2, which is to target the right scholarships. We have JPA and MARA for local and international studies, MyBrand SC for pure sciences, and internationally, the IAEA Mary Skłodowska-Curie Fellowship Program and the Fulbright ANS Fellowship for nuclear science students. So money doesn't have to be a barrier if we keep a good grade. Challenge number 3 is the public perception and nuclear stigma, where people still relate nuclear with the Hiroshima and Nagasaki incident, which is one of the biggest barriers in Malaysia, where people tend to be scared with the word nuclear. So to fix that, we can become a science communicator. This is because the government run public education programs, exhibition, and media campaign, but they need a young, passionate scientist to help. So in this way, we can volunteer for school outreach or write simple article or join competition like the 3-minute thesis to practice explaining complex topics clearly.
Why you walk so fast? I search for you, I want to ask. So instead of working in the lab, we should talk to people.
Yes, one day one of us might be the face of the nuclear science in Malaysia, so helping the public to understand that modern thorium hybrid systems are designed to be safe.
Okay, I get it now. Continuous self-development isn't about just study harder, it's about build skill and gaining experience.
Yes, exactly. 2 things for us as Malaysian students, which is to study hard and also to gain experience.
Wow, I'm so excited!
Yes, me too!
I